Assalamualaikum warahmatullahi wabarakatuh. Today we are going to continue our previous lecture on BQS552. We were in the topic of deep foundations, and we still are proceeding with the second part of the lecture. Okay, so previously we have covered on the displacement piles. Okay, we were talking about co- concrete preform piles, okay, which is a part of the displacement piles. Okay, so remember these photos. And today we will continue, still in the topic of displacement piles, but this time it's on timber uh, preform piles. Okay, all timber used for permanent work should be treated with suitable preservative, whether they could be tannalized or pressure treated. This is to ensure that it would last a very long time underground, being able to withstand the um, attacks from elements such as sulfur and underground insects. So these timber piles are usually square sawn and should be fitted with steel or iron ring at the head to prevent brooming. That is the crushing and spreading of the timber and splitting. Okay, so different. It's a bit different from concrete preform piles. That is, timber piles, if being subjected to extreme load, extreme impact, it will start to have issues such as brooming, meaning that the timber head, the part of the timber which is in contact with the um, maybe the piling hammer. Okay, so that part of the timber head will start to crack or experiencing brooming. Okay. So that timber head should be equipped with an iron ring. So the toe, in the other hand, should be protected. Okay, because it needs to go through maybe a very dense soil. So it should be protected by an iron shoe. The tip of the timber pile usually being reinforced by installing it with an iron shoe to assist in terms of penetration. So driven by drop hammer, so it should be equal in weight of the pile being driven for hard condition, or half the pile weight in soft conditions. Okay? So you can only go as far as the same equal of the pile, where weight of the drop hammer is concerned, because we do not want to stress out the timber preform piles too much. Okay, so this is the iron ring, okay, where we protect the pile head against cracking or brooming. This is the iron shoe, okay, a metal shoe to assist the timber pile in penetration, especially in hard conditions. In difficult driving conditions, pre-driving or pre-boring of hole for the pile should be adopted rather than risking undetected splitting or breakage of piles. So there is a condition basically when this pile needs some assistance, especially when the ground is very hard. So we might want to assist the timber piles by pre-drilling the hole or making the ground less hard. Okay, soften it up a bit. Okay, anything to avoid failures of the timber piles in the ground. The splicing of timber piles can be achieved by using steel channels, plates, or purpose-made box sleeve sections with butt ends of the piles being accurately squared off. Okay, I'm not really sure we have that. Basically, when we want to connect one timber piles with another, there are numerous ways. Um, Using steel channels and plates is fine for normal conditions, but in very rough conditions, we can use box sleeves. These are steel boxes which would connect one end of the pile to the other. So the advantage of timber preform piles is relatively cheap, okay, compared to other types of pile. In a sense, that has changed, okay, because timber is not cheap anymore, especially properly pressure treated timber. Light and easy to handle. The workability is great. Can be cut and drilled easily. You can work with timber piles relatively easily. And resistance to shock. Is able to absorb some of the shocks from the drop hammer. Disadvantages: insects and fungi attack. This is true, especially for timber piles which have not been treated properly. Cannot be installed in a low headroom area. Okay, we need to have a large headroom. Splitting and brooming may occur in hard driving, so we might want to avoid driving the piles into uh, hard ground. Okay, and the required length may not be available because the length of the timber piles depends on the supply. So yeah, you might need a lot more connections than what you think. Okay, next is on steel preform piles. So the use of steel preform piles are more suitable to the construction of marine structure. The most common types of steel piles are box pile, tube piles, H section piles, and screw piles. Okay, so box piles can be formed by welding or riveting sheet piles together, or by producing purpose-made section box pile sections. And then box piles in general are driven open-ended, meaning that the pile head is not being welded with any type of plates. And shoes or plates can be provided if it's required. So this is some example. This is not a box pile. This is a sheet pile being worked into position. Steel tube piles are basically consist of welding a plate which has been formed into a continuous helix. Tube piles are usually a bottom base driven with an internal drop hammer. So it's being driven through the void of the steel tube piles. We don't drive it at the end. So these are some of the examples. You can see that the steel plate is uh, bent into a helix shape to form this cylindrical pile. Okay. So this is how the steel tube pile is being driven. This is for the construction of a deck, a marine deck, or maybe a jetty. And due to the characteristics of steel that rusts easily, it is being protected by installing a zinc anode, okay, to the body of the pile. Tube piles are fitted with welded flat plate shoe and are driven by means of a drop hammer striking on a plug of earth dry concrete. So at the bottom part of the steel piles, they are being welded, and that is what is going to be impacted by the drop hammer. Okay, so instead of driving the piles from the rear end, we are driving the piles from the head. Okay, so reinforcement is not normally required for this type of piling since the tube remains in the ground as a permanent casing. So it's already steel. We don't really need any type of reinforcement. The next type is the H pile or universal steel beams may be driven with any type of hammer or vibrator. However, it will be protected with various form of protective paint. Okay, so this is an example. Usually we use it for superstructure purposes, but it can also be used for substructure purposes, especially for piling. So the advantages are guaranteed integrity of the pile after driving. So unlike the timber pile, which has a risk of failures in driving, the steel H piles will not have that kind of issue. Ease of stacking and handling on site. Okay, you can see it's very easily stacked one above the other. Ideally suited for the support of heavy axial loads and bending moments. So it does not need any special arrangement of reinforcement for countering any axial loads, lateral loads, or bending moments from the wave of the ocean. As a matter of fact, it does not need any reinforcement at all. Okay. Suitable for very hard driving and have a small displacement. Yeah. So in very hard ground conditions, you can drive it without any issues. Because another reason for that is that it has a very small displacement. When it's being driven into the ground, it only displaces a small amount of soil. Okay, due to the nature of the what they call it H piles, okay, which has a very small cross section. And the next type is screw pile. So it's still under the steel preform pile. It's just being the way it's being installed is different. The screw piles comprises of shaft or cylinder with its lower end fitted with a large the helical blade. Okay, so these piles are screwed into the ground instead of being hammered into the ground or vibrated into the ground. So it needs to be screwed into the ground by applying torque at the upper end of the pile shaft, which may be hollow or solid. So it's the same on how we drive screws into the wall or such. Okay, so this is an example of a screw pile. Okay, so it has a cylinder shaft, and then it has this helixes. Okay, that would help to drive the screw into the ground, and a 45-degree cutting end. It has the advantage in the uplift resistance in very soft ground and also provide good resistance to lateral forces. So the advantage of the steel screw piles that it has a great resistance against what they call it, uplift. Okay, so especially in marine construction, where sometimes the soil condition is very soft, and let's say for a jetty that's being built in open waters, it will experience a lot of lateral forces, and sometimes that lateral forces are so great that it would like to uplift the structure from the ground. So if you are using screw piles, it will prevent this from happening, because a normal pile is being designed to receive load, meaning that we have a load that's pushing the pile into the ground. It is not being designed to experience the opposite of that load, meaning a load that is going upwards, that is trying to pull the pile from the ground. So it's not being designed for that, especially for displacement piles. So to overcome that, for displacement piles, a screw pile would be a better solution. Okay, so this is the head of another example of a steel preform pile. Okay, so in general, the advantages of displacement piles, we have a better control and curing of piles, because normally this is being done at the factory. It is not affected by any chemical reaction of ground salts, because it's not being built in situ. Again, can be driven underwater. It's not affected by the water. Can be used immediately after driving. No curing required. Yes. Mass production, therefore, more economical. Okay, we can produce a lot of these displacements piles at the factory and just being brought to site. The disadvantages is what I've just mentioned, the transportation aspect of it. It's difficult to transport and handle, very heavy, because the pile can be very long and needs to be maneuvered through tight spaces. Okay. So that's why, especially for construction, the process of bringing in the piles would usually uh, been done through the waterways, meaning the piles will be loaded up in barges rather than using the land transport. There's a special need, design consideration to head and shoe to resist stress. during handling and driving. Okay, because the pile is being designed to be positioned vertical and to accept the load vertically, meaning head, uh, from the head of the pile, and the load shall travel to the shoe. So during transportation, where the pile is on its sides, okay, so it's being laid down. If the pile is not being supported properly, it will experience load that's coming from its sides. So that is cannot be good for the piles because it will be experiencing, in its case, load from the sides of the piles. So that is not something that the pile has been designed for. Wastage, okay, because pile cannot be cast to the correct length. So that's why when the displacement pile has reached where it is needed, it needs to be cut off and needs to be hacked, okay, in order to expose the reinforcements. Okay, so there's no actual length for displacement pile, and there's a possibility of breakage, meaning that normally displacement piles are relatively strong, but if you overdo it, there's a possibility that the piles will fail. And what's worse, that the failure happens underground. Okay, so next, the length of piles is restricted by modes of transportation. This is especially when you have to transport the piles through very congested, maybe town areas. So it's very hard to maneuver these long piles through these areas. Lengthening and shortening of the pile may be laborious and costly. So when we need to add more piles to lengthen the pile or need to cut it, that is an extra cost for us. Okay, next we move on to replacement piles. Replacement piles. These are often called board piles since the removal of the spall to form the hole for the pile is always carried out by a boring technique. So the prerequisite for these replacement piles is to have the soil to be bored by a boring machine to create an opening, okay, for the uh, construction of these board piles. So it's used primarily for cohesive subsoils for the formation of friction piles, also known as the board pile. So uh, we usually use these board piles in cohesive subsoils or in areas where the layer of load bearing subsoils are just out of reach. It is too deep to be reached economically. So that is when we use this replacement or board or friction piles. So it's also being used on sites where vibrators, which is the allowable amount of noise and or vibration, is limited. Okay, so we can use this ball pile to as an alternative for the use of displacement piles, where displacement piles create a lot of noise and vibrations, where the replacement piles doesn't have those kind of thing as much. And we use it also where the ground heave may be a nuisance or cause damage to surrounding structures or services. So we do not want the ground to heave or to move due to the use of numerous displacement piles. So that can cause damages to the facilities around the construction site, to the roads, to other buildings. So we do not want that. So we use the bore piles. The ground is drilled or bored to a required depth, and reinforcement cage is then inserted. This is the construction process. So when they have the piling point, it will be drilled to a required depth. This may be done with casings or any other type of support. And then a reinforcement cage will be inserted. And then the hole is then filled with concrete by means of a trimming pipe to prevent segregation of material. Meaning that when the cage is already in, then we insert this trimming pipe all the way to the bottom of the drilled hole. And then we will fill it up with concrete from the bottom up. Replacement piles can be enlarged at the base to carry and increase load. So this is another advantage of using replacement piles, where the end can be enlarged to distribute the load over a larger surface area. So it is known as under-reaming or felling. So once that is being done usually during the boring process. So first they will bore the shaft of the bore pile. Then only after that they will put in another equipment to create that under-reaming or belling process. So the replacement piles may be unsupported or supported piles. So for the unsupported piles, normally being used in stable soil conditions. So we do not need any type of support to prevent the soil from crumbling into the drilled holes. Okay? So it is often possible to bore drill an unlined hole, meaning that an unsupported hole, okay, with a mechanical auger or percussion tool, and to place the concrete without lining the hole, without any support. Whereas the supported piles can be divided into two categories. Either it's being supported with permanent or temporary casing. So with the permanent casing, the hole is formed by means of percussion or rotary drilling. A heavy cutting tool dropped from its mounted position to cut out to the hole that's being prepared. Okay, so this is the auger that's being used for the boring process. This is a special type of auger that's being used for drilling through hard ground where there are stones or rocks inside the layers of soil. You can see there are a diamond tip plate here to cut through the to the layers of rock. Okay. So the heavy cutter is raised by a diesel operated winch. Okay, so they have a winch, and the operation is repeated until the hole has been sunk to the required depth. As the cutting proceeds, a thin sectional of lining is introduced into the hole to prevent its collapse. Okay, so this is how they drill with the lining. As you can see in this photo, there is a metal cylindrical lining, okay, as they bore to the required depth. The lining is formed with screw joints to facilitate alignment and to prevent ingress of water. So that's how the lining is being connected together. The reinforcement cage is lowered and concrete is poured by means of trimming pipe, as mentioned before. So these are some of the examples of the reinforcement cage for the ball pile. As you can see, it comes as a complete unit, um, and it can be quite long. So the process of putting it into the hole will require some sort of crane, okay, to put it into from the horizontal to the vertical position. Next is the temporary support. Okay, so the temporary support is usually being done with the assistance of mud or and water. Okay, so we are not using some sort of a metal lining here. The hole is supported by a let me check. Yeah, this is where the process is using. Okay, next is the temporary support. Such we are supporting the hole by using temporary lining and also using drilling mud and water. So the hole is supported by a screw jointed steel lining or casing, which is retrieved either when the concrete has been placed or during the placing of the concrete. So the lining shall not become a permanent feature of the ball pile. Number two, the casing may be winched or jacked out of the ground. Okay. The inner core of the pile usually is in situ concrete or precast concrete unit pressed into the ground as the casing is withdrawn and pressure grouted on completion. So, alternatively, the casing may be vibrated as it is withdrawn, producing a rib finish to the part and giving greater skin friction. So, as the lining being taken out, it will be vibrated. So, this will allow the concrete inside the hole of the ball pile to really seep into the ground, uh, so that it will have greater friction against the soil. Where a large diameter pile to be sunk in unstable ground, the ground may be supported by the use of drilling mud, or known as the bentonite slurry. So the mud consists of bentonite, which restrains the particle of soil and forms a membrane over the sides of the borehole. So when we start to drill for the borehole, at the same time we will pump in this bentonite, because what we are doing is creating a void in the soil. So that will cause the wall of the borehole to collapse. But if we drill and at the same time we pour this bentonite into the hole, this means that there won't be any void inside the borehole, so the wall of the borehole will not collapse. The first stage boring, aligned with a short temporary steel casing, and then the hole is filled with bentonite. So the boring continues through the bentonite, which is continuously fed into the hole as the boring proceeds. So upon reaching the required depth, the reinforcement cage is lowered through the bentonite and the concrete is placed through a trimmy tube. So the bentonite is basically mud. Okay. So it will not have any issues with we trying to put in the reinforcement cage into it, okay? Or we want to pour concrete because the concrete will displace the mud. So the concrete is a lot denser than the mud. So when we pump the concrete from the bottom up, the mud will be displaced and collected to be used again at other boreholes. So which is pumped back into the storage tank as it rises up the borehole. So it will be collected and being used to other borehole. It is then strained to remove soil particle before reuse, and the short temporary casing is then withdrawn. Of course, there will be soil particles in the bentonite slurry, so it needs to be removed by sieving before being used again. As the hole is bored, water is pumped into it. Water flows through a hole in the cutting tool through a drilling rod. This is the process of when they are boring the hole. We use water to assist in the process of boring. This technique allows the cutting tool to remain in the borehole while the spoil flows out via a drilling rod in the settlement tank or ditches. So the drilling stops when the required depth has been reached, but the water flow is maintained. Concrete is then carried out by means of 3 tube and displacers of water. So this is the use of water instead of the bentonite. Okay, uh, because we if we don't have the access to bentonite, we can also use water. So when the borehole is being drilled, we pump in water. It will help in the process of boring, but it will also allows the spoil or the soil that has been excavated to flow out of the borehole. Okay. Uh, at the same time, it will come out with the water. Okay. So even when the drilling stop, we will still pump in water because we need to get the spoil out of the borehole. Okay. Only then we will start concreting from the bottom up, and at the same time, the concrete will displace the water out of the borehole. So this is an example of a 3 tube. Okay, so once the borehole has been prepared, we will have this hopper, and then we have a long tube that goes all the way to the bottom of the borehole. So this is when we will pour concrete into this hopper, and the concrete will travel through the tube all the way to the bottom of the borehole first. So we don't just throw in concrete into the borehole because that will create a lot of segregation and air pockets in the concrete. So we must use the trimmy tube, or trimmy pipe. So this is a photo on the condition on site. You can see a lot of boring rig and also the reinforcement cage for the bore pile. Okay, so this is the lining for the borehole. So it's either being put in or taken out. Okay, the span lining is being put on the sides. Okay, because they are working on this borehole. You can see there's a load test on a pile. This is the vibrating machine. Okay, normally being used to take out the steel lining from its position. So we want to take out the lining from the borehole. We put this vibrator and it will clamp at the end of the steel lining and will start to vibrate, which helps in the process of taking out the lining from the borehole. So this is the area where they prepare the steel cage for the bore pile. Next, the advantages of replacement piles. Comparatively lighter reinforcement required due to the absence of handling and driving stress. So we do not need as much reinforcement as displacement piles because the reinforcement settings or layout of displacement piles is a lot more elaborate because it needs to deal with the stresses of transporting it on its sides, okay? And also the stresses during the driving process. So for the replacement piles, it does not have to consider this process, so it would require lighter reinforcement. Piles can be cast to exact length required, no wastage. Yeah. So there is not as much wastage in replacement piles as compared to displacement piles. It'll be easier for the uh, QSs to estimate the uh, materials needed. Yeah. No cutting required, meaning that length, very long length cutting are not required. Maybe it just needs some what you call it, hacking in to connect it with the pile head. That's all. Easy to maintain verticality because the verticality always depends on the boring process. If during the boring process you are able to maintain the verticality of the borehole, then there shouldn't be an issue of the verticality of the replacement piles. Whereas during a displacement path, during the driving, it might want to shift to the side. Okay, the pile might want to shift to the side. So it's very difficult to recover from that. The exact number of piles required can be determined. Okay, we can't do that as much with displacement. And transportation difficulty is eliminated because the pile is being constructed in situ. So that's the advantages. Next, the disadvantages of replacement piles. Position of reinforcement may be disturbed during the concreting of pile. So, yeah, we have to maintain the verticality of the reinforcement cage. Okay, so that's why for sometimes for higher quality, the reinforcement cage must be constructed by or connected by the use of welding. We cannot use any more of these wire ties because we want the reinforcement cage to have some degree of what you call that. It must be rigid. It cannot be a bit of flexible. Okay, because during the concreting, the reinforcement might get out of position. If the reinforcement cage is being welded together using very high quality reinforcements, so that reinforcement cage can be quite rigid, so it will not have any issues during the concreting process. Difficult to cast underwater. Yeah, we can't really build a ball pile underwater, meaning you will need special precautions, special preparation. May need to build caissons, maybe coffer dams, things like that, before you can start building the ball pile. So that's why usually for marine construction, they will resort to the use of displacement piles rather than replacement piles. Less quality control on site, yeah, this is typical of any in situ construction. Quality control is totally up to the contractor, whereas for displacement piles, quality control is at the factory, which is a lot greater, better managed than on site. Void honeycomb impasse may result in failure of piles. So this is very bad news if there are void or honeycomb in the piles, meaning that during the process of putting in the concrete, the contractor did not use a trimmy pipe, okay, or maybe did not have enough vibration during the process of taking out the lining of the ball pump. So if they want to avoid this, they have to really use a proper trimmy pipe during the concreting and really shake up the ball pile through the lining, okay, to ensure that the air pockets was removed from the ball pile, but not too much that will cause segregation. Next is the raking piles. Okay, so what is so special about this raking piles? Piles can be arranged in a number of ways so that they can support load imposed of them. So what we were talking about earlier, displacement, replacement piles, they are vertical piles. So it can be designed to carry vertical loads as well as a lateral loads, okay, a certain degree of lateral loads. If required, the vertical pile can be combined with raking piles to support horizontal and vertical forces. So these are diagram of vertical and raking piles. So the one on the left, these are totally vertical piles. We have 16 piles in a group, and all of them are vertical piles. So compare that to let's keep the center, the right hand side, okay, where we can see that the piles at the edge of the pile cap. Here, 1, 2, 3, 4. These are raking piles. Piles that has been prepared or driven at an angle uh, compared to the vertical pile, which is totally like 90 degrees. The raking piles are being prepared or driven at an angular position. Okay, so what this does, sorry about that, it will increase the surface area down here. Okay, compared to this left one. Okay, the load of the that they receive are being distributed at a smaller size area compared to this one. Maybe the same load, but is being distributed over a larger area. So this will help in increasing the strength of this pile, okay, which is being equipped with the raking pile. So that's a great advantage, okay, of raking pile. So you are able to distribute the load of the structure to the solid ground beneath over a larger area. However, the raking piles, the cost of building or driving raking piles normally is a bit more expensive than your typical vertical pile. So this is something that needs to be considered by engineers, especially during the design process. Yeah. Okay, so with that, we have ended our lecture on piling and deep foundations. So thank you very much for listening in. Assalamualaikum warahmatullahi wabarakatuh.